Today we are exploring an agent-based model called the communicating hazard information in the modern environment. This NetLogo-based program enables the analysis of how information flows and how protective decisions are made over time and space during hazardous weather events. So, by leveraging real world data from historical hurricanes and forecasts, this model offers a way to test hypotheses about collective human responses to weather information. So, before we begin, could you please introduce yourself?
Sure. I'm Dr. Sean Bergen. I'm an assistant research professor at the School of Complex Adaptive Systems at ASU. And my focus is on agent-based modeling of human and landscape interactions.
To start, what are the main objectives of this model? What does it aim to reveal about decision making and information flow during hazardous weather events?
Sure. So I think, these days there's a large amount of information that can come at somebody experiencing a hazardous weather event. And that could be something that's just as simple as, what's being broadcast on the television, information coming from officials in an area, well, your local government. Um, it can be, your family, it can be your friends. There's a large amount of different sources of information. And so what we aim to do is sort of incorporate all these different types of sources of information and try and model how people make decisions during a hazardous weather event. We specifically look at hurricanes most of the time in Florida, although there's also one hurricane from Texas included, to try and understand sort of how when people evacuate and sort of what the important factors are that make them make their correct or sometimes incorrect decision. Um, so I think agent-based modeling really gives us a great platform for that because especially with a hazardous weather event, one of the things that's really important is it's not just that information flows, right? All these different information flows, but also where you are. So, if you picture the Florida Peninsula, a hurricane can come from the west side or the east side, and not all of the agents in the simulation should be evacuating. Or there might be information that is incorrect. These little cones and stuff, they change, and so in some of the storms in the past, large cities were sort of in the direct path, and then a few days out, the hurricane changes, and so then the information changes, but people have already decided to evacuate, or are they checking it quickly enough to stay in place? Because sometimes that's the right decision. Um, so I think the agent-based model can include a large number of these factors of communication and environment and things that are all critical in understanding how people make decisions.
Let's discuss challenges. What were some of the significant difficulties you encountered while building the model and developing it?
Yeah. So I guess I would say there's probably maybe two or three main areas. One is simply just human decision making, right? I mean, we're all complex. People can't even, people do it for just as a side note. I mean, there are a large number of surveys, analysis done where people go in and talk to people after a hurricane. They say, okay, why did you evacuate? Why did you stay? And they don't have a good answer. They come up with an explanation, but because it's so many different pieces of information all coming to somebody at once, it's very hard to even get somebody to explain why they made a decision. Another thing is just the simple fact of getting sort of the GIS information of a storm. Because we include not just where a storm hits, but in real time where the storm looks like it's going to hit every hour. So in the model, the forecast is updated every hour, just as it was historically. So getting all that information in from a programming perspective is very difficult. Um, and then validation too. Trying to understand, it's fun to make a model, but trying to actually understand if the model is at all correct. You know, you can say, well, look, all these agents evacuated. My model is great, but validating that is something that is actually still something that we're in process doing, and finding the data set to do that.
Let's talk about findings. What patterns have you observed in, how people respond to weather forecast? Any surprising trends in decision making or protective actions?
I should back up and say that I'm not the only author of this model. I'm sort of the secondary author. The original author's name's Josh Watts.
Yep.
But one of the things that I added in was not just census data for location, because figuring out where to put the agents and how many in one place, because they're not uniform across space, obviously, but also using census data for sort of socioeconomic information. So, for example, census information can tell you, there is 30% of the people in a county live on food stamps. And so we can infer that those people are probably less likely to evacuate because they're not going to have the financial means to just run off and get in the car and go to a hotel. And there's information on the number of people who have cars, children, age. And I think, I guess one of the preliminary things that I would mention is that a lot of those factors didn't make our data more accurate, which I actually thought they would. I thought, okay, the more detail we included, the better our match is going to be to the cellular data. But one that seems to improve things is specifically looking at the groups of people who are over the age of 65, retirement age in the U.S. And, including the factor that those people are less likely to evacuate. That does seem to improve our results. But like I said, too, we're still analyzing and comparing to that cellular data. So I think there will be more trends to come for sure.
On accessibility, how did you prepare the model for public use? Were there challenges in making it user-friendly and well-documented, and making it available using ComSys.net?
Yeah. Making it reusable specific for people was one of the key goals of this model originally, with the idea that you could see a new storm coming and then try and then use our model to predict when the type of information to share or when to share different types of information. And so, and I think I'll say we have mixed success, because if I was to give you this model right now and say, okay, there's a hurricane coming for Florida, go run it, you could pull in the weather information, right? So that's one system, that's one source of information from the NOAA that you could access, and the census information is there to compare it if you want to do that. But that's Florida. So we only have Florida and Texas included. If there was a hurricane coming towards South Carolina, unfortunately, you would have to get a map and import it yourself and pull it in. So it's not something that sort of, the average person could do, unfortunately. It still requires some work. But we've tried it's been programmed in such a way that you could pull in a GIS data for different places. And you could pull in census data for other places. And those are complicated steps, but it's definitely accessible to other people. So that is one of our goals, and I think we've have some success there. I think one of the future challenges we're going to have too is that, at least for validation, the data set that we have access to is not one that's publicly available. So we have to, compare it to the cellular data set that we were granted access to, but it's not our data. And so unfortunately, we can't just put it on ComSys or put it on a website with a published paper or anything like that. And, that data is a little scary too, because, I don't know about you, but I've read multiple times that even though it's supposed to be anonymous, that people can then use that information to trace back individuals and infer different people. And I suspect that our data is generalized enough that that's not possible, but it's always a concern.
So finally, as you mentioned about the applications in different places, What's next for this model? Are there plans to include new data, expand its scope, or, explore other applications?
Yeah. Well, as I sort of mentioned earlier, we're currently writing a paper to compare it to that cellular data. So that's sort of our biggest next step. That first paper, outlined how important this type of model can be, and so I think the next step is to then show sort of what types of factors can actually replicate the patterns that we see, and sort of validate as much as possible our model against what is technically another model of evacuation when we use the cellular data. And so we're in the process of conducting like tens of thousands of replications, and we're looking at the data 100 different ways. And so I think that is our next major step. I think down the line, I hope that people might use this model, or at the very least build upon the ideas and say, look, here's a model of not just people getting into cars, running and evacuating, but of people actually making these decisions. And ultimately, our goal too is to sort of better to make suggestions about how people give out this weather information, right? So, and the best ways to give people information. So, down the line, you could try and say, okay, what is the perfect scenario of when everyone evacuates? Because right now, technically, we're trying to say, okay, our model replicates what happened, but what happened isn't perfect, right? So we can try and understand what would give the perfect result when everybody who should evacuate does, and the people who don't need to evacuate stay put, because all those people are clogging up highways and filling up hotels when other people need it. So I guess one of the other sort of future directions or things that I'd really like to do is try and look at it from a like, how do we get the best result perspective, not just how do we replicate the past. So once we have the model validated, then you can say, okay, this could improve things.
Exactly. Okay. Thank you very much for joining me and sharing your insights about this valuable model.
You're welcome. Thanks for having me.